In this video, we're going to take a look at how titrations work when we look at neutralization reaction. What we're going to be doing is this. We're going to be taking 25 ml of 1 molar H2SO4 and seeing how much of 3 molar sodium hydroxide is necessary to bring about neutralization. And so we're going to call that XML. Now the maths is quite simple. Let's just review it. The number of equivalents of H2SO4 in 25 ml of 1 molar H2SO4 is given by moles times n factor. Moles, that's going to be equal to the molarity times volume times n factor. Molarity is 1, volume is 25 ml, we need to divide by 1000 because we need to convert to liters, and the n factor for H2SO4 is its basicity, which is 2. And we get 0.05 moles. Now when we talk about XML of NaOH, using an identical argument, the number of equivalents of NaOH is the molarity, which is 3, times X by 1000 times the acidity of sodium hydroxide, which is 1. Now as we know, for a neutralization, equivalence of acid equals equivalence of base. So we equate this to this. So we get 3 into x by 1000 equals 0.05. If we solve, we get 16.67 milliliters. Now let's try and do this experiment in a virtual lab and see whether this is exactly what happens. Here's our lab. Let's first assemble what we need. We're first going to need a beaker. We're going to need a burette. And this is how you would do it in an actual lab. Our materials are 1 molar H2SO4, and I've got that here. I need 3 molar sodium hydroxide, I've got that here. And then finally, I need an indicator. I'm going to choose phenolphthalein. Phenolphthalein is colorless in an acidic medium, but turns pink when the solution turns basic. So, let's take this beaker, and to it, let's add the 1 molar sulfuric acid. And at the bottom, I'm going to say 25 ml. I've just typed that, and I'm going to say pour, and we see that we've poured 25 ml into the beaker. And if you see, the beaker now over here has a volume of 25 ml of fluids in it, and we know that fluid is only sulfuric acid. I'm going to take away the H2SO4, and now I'm going to add a drop of phenolphthalein, just 1 ml. Okay, because it's an indicator, so just 1 ml, and that should take the volume to 26 ml. Take away the phenolphthalein. As we can see, the volume for the beaker, I've just clicked on the beaker, is now 26 ml. Now I'm going to take this burette, and into it I'm going to pour 3 molar sodium hydroxide. Let's say I take 25 ml of it and pour it. I take away this sodium hydroxide, and now we're ready to do our titration. So I set up the apparatus, and now I'm going to start putting the sodium hydroxide, which is in this burette, into the H2SO4, which is in this beaker with the phenolphthalein indicator, in 1 ml moves. So here's 1 ml. Now I'm going to pour 1 ml. So note that the contents of, let's look at the beaker, the contents of the beaker, the volume is currently 26 ml. 25 from the acid and 1 ml from the phenolphthalein. I start pouring 1 ml at a time, and I've just poured 1. As you can see, it's now become 27 ml. Okay, so let me pour 15. 1 is gone in. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now I've poured in 15 ml. Now I need to be very careful. Okay, I'm going to pour in the 16th ml. I just did that. You see it's gone to 42. But you can see that this color is still colorless of the phenolphthalein. Now note what happens when I put in the 17th ml. Remember from the calculations we said that we need 16.66 ml. So when I put in 17 ml, then this solution in the beaker now has an excess of base of sodium hydroxide and therefore should turn pink. Let's see if that's what happens. Here we go, I pour 1 ml and there we see that the beaker has indeed turned pink. What you've just seen is a titration, and it's used in many different ways, some of which we'll discuss in class.